Question 1. Consider the following method. Public static int mystery integer array in x equals 0, for in k equals 0, k less than r dot length, k equals k plus 2. Inside the for loop, x equals x plus the current array member you're looking at. So you're totaling up the array members you're looking at in the loop, and then at the end you're returning x. Assume that the array nums has been declared and initialized as follows. An integer array containing 3, 6, 1, 0, 1, 4, 2. What value will be returned as a result of the call mystery nums? So if you put this array into this method, what gets returned? Well, this method is adding up every other element of the array. So 3 plus 1 plus 1 plus 2 is 7, so C. Question 2. Consider the class, public class, sum class, private int my A through C, public int get A, you return my A, public void set B, given the value, you set that to my B. This declaration appears in another class, sum class obj equals new sum class. What code will compile without error? You can right away throw out B and E because they make it seem like get A takes an argument, which it doesn't. You can throw out C because my A is private, and you can throw out D because get A is not a static method, which leaves you with the answer being A. Question 3. Consider the class, the same class from the last example. What change to some class will allow other classes to access but not modify the value of my C? A makes it so they can both access and modify. C would make it so they could access but they wouldn't be able to modify. D and E are nonsense, so the answer is B. Question 4. Consider the code int x equals 7, int y equals 3. If x less than 10 and y less than 0, print out value is x times y, otherwise print out value is x divided by y. What code is printed when this is ran? Well, x is less than 10, but y is not less than 0, so we'll print out x divided by y. This is 2 in some decimal numbers, but this is integer division, so the answer is just the 2, which means the answer is C. Question 5. Consider the method. You return an array list, and you pass in a number, and in this loop, every element in the array list you're adding is whatever the loop index is, squared plus 3. So it will be 1 squared plus 3, 2 squared plus 3, 3 squared plus 3, all the way up to whatever this number is. What is printed if you print the result of mystery 6? So 1 squared plus 3, that will be 1 plus 3 is 4. 2 squared plus 3, that will be 4 plus 3 is 7. 3 squared is 9 plus 3 is 12. 4 squared is 16 plus 3 is 19. 5 squared is 25 plus 3 is 28. 6 squared is 36 plus 3 is 39. So C is your answer. For question 6, there's this big long blurb to basically ask, how do you determine if two floating point values are almost equal? And the answer is E, as the absolute value makes sure that the order of the two numbers doesn't matter, and that expression is basically checking, is the distance between these two values basically negligible? For question 7, a whole person class is declared. Assume a declaration has been made where a student variable equals new person with a name of Thomas and a birth year of 1995. Which statement is the most appropriate to change the student's name to Tom? A is making the original person variable no longer exist. B is wrong because my name is private. C is wrong because that won't change the name. Finally, E is wrong because setName is not a static method. So D is your answer. For question 8, a whole student class is declared. Which declaration will compile without error? 1 and 2 are fine, but 3 won't compile without error as it's trying to pass in 15 as a string. But the method says it must be an integer. So the answer is C, as only 1 and 2 compile without error. For question 9, all you're doing is seeing the proper code snippet to properly complete the code. Since you're starting at 1 and wanting to go to the end of the array, the proper code snippet will be B, as it's looking back 1 for every element, which will make sure you sum up every single element. For question 10, the code is basically describing a flawed linear search, starting at the end of the array, and then going back by 1 each recursive call. The reason it's flawed, though, is there's no condition to return a -1 if the element isn't found. Given that, the answer is B, as the array not containing 5 is the only way that calling the method with an argument of 5 would result in an error. The code for question 11 describes a flawed linear search that starts at the end of the array and moves back by 1 with each recursive call. However, the function lacks a condition to return -1 if the element is not found. Therefore, the correct answer is B. If the index becomes negative, the function has searched through the entire array without finding the element, so it should return -1. Question 12's code combines every other character in the string starting from index 1 using a substring call with a step of 2 that includes the start index, but excludes the end index. Therefore, the correct answer is C, which represents the result that starts at index 1 and combines every other character. Question 13's code loops through an array printing an element's index and value if it is greater than the following element. The loop stops one element before the end. Thus, the answer is B, where the elements 7, 5, and 3 have indices 0, 2, and 3 respectively, and are greater than the next element in the array. Question 14's code presents an interface in a class. A, B, C, and D are incorrect, since they either do not call get mileage or do not consider V as a vehicle. Thus, E is the correct answer. Question 15's code presents a flawed is-sorted method that only checks the first element before making a decision. Therefore, the answer is C. Question 16 copies two arrays into a larger one. The correct replacement for the I comment is K plus A1.length, as it ensures that the second array is written after all the other data already copied from the first array. Therefore, the answer is D. The code for question 17 copies adjacent array elements to the current element starting from index 4 and stopping one before the end. The answer is C. Question 18 asks how to use math.random to get a valid array list index. Math.random generates a decimal number from 0.0 to 1.0, with the end not being inclusive. Multiplying and casting date creates integers from 0 to array list size minus 1, so the answer is B. For question 19, applying De Morgan's law to the given expression involves flipping the and to an or and distributing the logical not to the two operands. Additionally, the opposite of greater than is less than or equal to, therefore, the answer is B. Question 20 is a variation of the swap algorithm where J starts at the beginning, K starts at the end, and if you swap the values from two different places, you reverse the array. Therefore, the answer is C. Question 21 does its best possible job to cover up the fact that it's asking how do you find if two floating point numbers are basically equal. Therefore, the answer is D, as that's how you find if two floating point numbers are basically equal. Question 22 describes a book class and an audiobook class. This question is incredibly tricky as answer choice D won't compile. Even though the book at index 0 is an audiobook object, once it gets put in an array of type book array, its audiobook methods can no longer be called. Question 23 is one there's really no quick trick to get to the answer faster. You can eliminate A, C, and E because you can see from the code that element 0 will never be touched. Other than that, you have to manually run through the code by removing and reinserting the strings that start with B and get to the end result that the answer is B. Question 24 is filling in a 3x3 grid of numbers from top to bottom and then left to right. The question ends up asking, what's the number in the top right of this grid? Therefore, the answer is D, 7. Question 25 gives you an interface and asks you why it's wrong. It's wrong because from surface area and volume alone, you can't extract the height, width, and depth of a box. Given that, that's exactly why the answer is A. Question 26 is a bit simplistic. How do you print all of the odd numbers but none of the even numbers in an array? For every number, you check that its remainder is 1 when you divide it by 2. If its remainder is 1, then it's odd. Therefore, the answer is A. Question 27 is covert Fibonacci code. It's asking, what is the sixth Fibonacci number? The sixth Fibonacci number is 8. Therefore, the answer is D. For question 28, the answer is E, as if point B is reached, n is greater than 2 because that's the very definition of how this while loop right here works. Question 29 asks, how do you equivalently loop through a list of numbers from 1 to 100 and only print out the multiples of 4? To do this, you would start at 4 and skip ahead by 4 each time. Therefore, the answer is D. Question 30 is asking, what happens when you concatenate two strings? The substring of compiler index from 4 to the end, this would be ILLER. The other string part would be the substring of the compiler index from 0 to 3. 3 because the end value of substring is not inclusive. That substring will be comp. Therefore, when you concatenate ILLER and comp, you get ILLER comp. Therefore, the answer is C. Question 31 modifies an array by adding each element to its immediate neighbor. The first element will stay 5 because the first element you change will be the element in index 1. 5 plus 2 is 7, so the second element will be 7. 7 plus 1 is 8, so the third element will be 8. And with that, you've eliminated every other answer choice except C, So the answer is C. Question 32 asks you what this code is calculating. You're multiplying n by itself k times, meaning the answer is C, n to the power of k. Question 33 induces an infinite loop because k never becomes greater than 4, or equal to 4. Therefore, the answer is E. Question 34 has a point class. To properly declare the center variable, you would want to be able to specify any values for a and b, so the correct answer is B. Question 35 is a bit of what I would call an unfair question. The only thing this particular thing is testing is if you can do this code mathematically. There's no real trick. Once you plug and chew through the math, you'll find out the answer is E. For question 36, you read these conditionals and you realize you need an even number, a number greater than 9, and a number less than or equal to 9. The only answer that fulfills all three of these conditions is the answer C. For question 37, you're wanting to know the condition for the while loop to only print 1, 3, and 5. Since you're starting at index 1 and advancing by 2, if your condition doesn't equal 6, you'd induce an infinite loop as x would never equal 6. Therefore, the answer is D, option 1 and 3. For question 38, there's really no way to intuitively get the answer, as you just have to remember how to reach the particular answer. A or B and C can be rewritten as A and B or A and C. Therefore, the answer is A. For question 39, you must follow through the recursion. Recur of 27 recurs recur of 9. Recur of 9 evaluates to 18. Recur of 18 then evaluates to recur of 6. Recur of 6 evaluates to 12. Recur of 12 evaluates to recur of 4. Recur of 4 evaluates to 8. And then recur of 8 finally stops the recursion and evaluates to 16. Therefore, the answer is D. For question 30, you're using recursion to gradually go through a string one character at a time and adding one more character on each recursive call. You end up stopping one character short of the end. Therefore, C is the answer as that follows through with what the code does. I normally make content teaching you how to code in Java, Python, and JavaScript, so if that sounds interesting to you, please subscribe.